All right, let's talk about vertex form. So it's my favorite form when it comes to quadratic function. There's three: standard form, right, which I call y-intercept form, x-intercept form, and then vertex form. And it's nice because you can actually see vertex form and then see the vertex and know kind of how it's going to graph right away. Now, from there, we usually use that to work on, so if we have a quadratic, okay, we start talking about inverses. It's nice because vertex form allows us to go quickly into that inverse. And we need it, right? We need it often. Sorry, let me just erase this. All right, so let's just go over the concept of vertex form, because a lot of times when it's first introduced, if we understand visually how it works, we can better understand how to work with it. And sometimes we just throw up the equation, y equals x minus 2 squared plus 4, and go do something with it, right? But I think of it as in different parts on this function make the graph do different things, right? So let's start with our parent function. So our parent function is going to be y equals x squared, right? The parent function of a parabola or a quadratic function, okay? From there, what I'm going to do is I'm going to move this graph, all right? So let's say that I want to move it to the right too. So I want it to now look like this, okay? Now, what do I need to do to this to change it? Well, when I look at right here and I say, okay, well, this point is 0, 0. And if I move it to the right 2, my new point is 2, 0. All right? So when I look at the inside parentheses, okay, and I'm going to make this look like this. So I know it looks like this, but I'm going to prove it to you. So what I want to know is what makes y go to 0? Well, in this form, if I plug in x equals 2 to here, I get y equals 2 minus 2, which is 0. 0 squared is 0. And it worked. It's exactly what I want it to do, okay? So that's moving it to the right. What if I want to move it to the left, okay? So here's my parent function, and I want to move it to the left. Well, I know this is still 0, 0, and this is negative 2, 0, okay? So now I'm going to say, well, what if it equals y equals x plus 2 squared? Does that work? Okay. So yes, it does. Y equals negative 2 plus 2 squared equals 0 squared, which is 0. Great. That's exactly what I wanted to do. Okay. So to move the graph left or right, the parent function, we're going to affect what's inside the parentheses. Okay. And what I use as a trick here, I say if it's either plus or minus, okay? And this is typically labeled as H. It's plus or minus. Plus means that it goes left, right? And negative means it goes right. They work in opposites, okay? So let's build on that. Now, what if I want to make it move up or down? Okay, well, same parent function, and I want it to go up by 2. Okay? Well, to move left or right, I'm inside parentheses. To move up or down, I'm outside the parentheses. So let's try y equals x plus, no parentheses, equals x squared plus 2, because it's outside the parentheses. So plus 2 goes up, all right? And I know that because, again, this is 0, 0, but this is now 0, 2. That's my new point, or my vertex right here. So if I plug in 0 for my x, I should get 2. And I do. Great. All right. Now, let's keep that graph up there just because it's easier to see it. Now let's move it down 2. Okay. So that point is 0, negative 2. So let's see if this works. Okay. Y equals x squared minus 2. So if I plug in a 0 here, do I get minus 2? I do. Great. Okay. So y equals x squared plus or minus k, and that tells me it goes up or down. So positive is up, negative is down. All right. Do something silly in class where I call this samesies, right? Because what's outside, it does exactly what it says it's going to do. Whereas inside, it is opposites, okay? So if it's positive, it goes left, negative, it goes right. So let's tie it all together, okay? And then we'll finish up with A. So my parent function, all right, is y equals x squared. To move it, I'm going to say x plus or minus h squared plus or minus k, all right? So inside, or h, tells me to go left or right, and it works in opposites. K tells me up or down, and it works in samesies, or the same. The last thing that's usually listed is A, y equals A, okay? So what is A? Well, A tells me two things. The first, it tells me whether it's going up or down. So if I had this as a negative, so for example, y equals negative x squared, then my parabola is actually going to point down. So anytime you see a negative out in front, for example, negative, let's just say negative x plus 2 squared minus 3, okay? The negative is what I automatically work with. I flip it over the x-axis, and then I'm going to make it go left 2 and down 3, okay? Last part is, so we talked about the negative, but what about if it's a number, okay? So the number tells me whether the parabola is going to get skinnier or wider, okay? So if A is greater than 1, then I know that it's going to get taller, okay? Or it's going to be compressed this way, so compressed horizontally, or stretched vertically, terms that your teacher may have used. And then if A is less than 1, then I know that it's going to get wider, okay? Because it's going to go out this way, right? So it's going to be compressed vertically or stretched horizontally, all right? So let's finish that last part one more time because it's a little confusing, right? So here's parent function. Actually, it's probably going to be a little bit wider. Here's the parent function, all right? And I want to make it go wider, all right? So I'm going to say, so if this is y equals x squared, I'm going to say this is y equals 1/2 x squared, okay? That's what's the A, all right? Because I'm still here at the origin. So like I said, less than 1, it is a horizontal stretch or a vertical compression. If I want it to be taller, then I might call that y equals 2x squared, okay? And this is a horizontal compression, right? It gets pushed in, or a vertical stretch, it gets pulled taller, okay? So that's it, right? It's really not bad. So the next time you see something that looks a little scary like this, you can automatically put the vertex and get yourself to where you have a rough sketch to know what's going on, all right? So let's finish up by doing this one real quick. So I know that it goes down because of the negative. It's going to go right 3, 1, 2, 3, because that's a minus 3, and it's going to go up 2. So flipped, right 3, up 2. I can give myself a basic sketch, but remember, it's a 2 out front. That means it's going to get taller or stretch vertically. So it's going to probably look something like that, okay? Maybe the last thing I would do is plug in a 0 for x and find out what my y-intercept is, but we'll save that for another day. So that's Vertex Form. It's not that scary, guys. Go ahead and like and subscribe. And then what I want to do is just keep building on these. If you have any specific questions, definitely add them in the comments, and I'll make different videos based around what you guys are struggling the most with, at least to get us started with just more overall videos in terms of Vertex Form, or really anything you have a question on, okay? Good luck, and hopefully you do well in your next test.